from that next. Okay, so here is the data that I came up with. I went ahead and matched up, so 0 and 0 would be my starting values, right? If we hadn't rotated all, it was not off the ground at all, and we hadn't traveled a distance. After one rotation, my distance was 1.5 inches, and the height of my point was 1 inch. And then I had 3 inches of distance and 2 inches above the ground, and as I continued to rotate it, I was traveling 4.5 inches each time, and gained an additional height until I got to where it was straight above the ground. Okay, so then that was a distance of 6 inches, and I was my diameter's distance from the ground of 4. But notice as we begin to continue to rotate, your height should get smaller because your point should be coming back down to the ground. Your distance will continue to increase because you're still traveling forward. So these are my data points that I got from my measurements. And again, be as accurate as you can, but me with running a webcam and not the best ruler in the world, this was as accurate as I could get. But please be as accurate as you can, and try not to use the same item as someone else. Be unique, find your own item so that you get your own values. The next thing we are supposed to do is take these values and make a graph of these values. They wanted us to use the distance as the x-axis and the height as the y-axis, and to graph that. Now you're more than welcome to do that on paper, draw out an x and a y-axis and do that, and then you would just either take a picture of it and attach it to your post, or scan it and attach it to your post. Okay, it needs to be in the discussion board, however. The other option is to do it, for example, maybe in Microsoft Excel or Microsoft Word. Right now I am in Microsoft Word, and if you wanted to put in a graph, you would go up here to Insert, and we're going to insert a chart. And I looked through the options, and this is really the one that works the best for this example. We're going to make a scatter plot of our results. And I want the scatter plot that includes lines so I can see the shape of my curve. Alright, so then that should bring up the chart for me, and then what I need to do is put in my values. So remember, they requested that we use x values for our distance and y values for our height. So for my first, I had a distance of 0 and a height of 0. My first rotation, I had a distance of 1.5 inches and a height of 1 inch. My next one, and I just continue on, then my next one, my distance was 3 inches and my height was 2. And I had 4.5, 3, and hopefully you get the point. These are my data points that I had, right? Then I got to a distance of 6 inches with a height of 4, and then 7.5 and a height of 3 again, and you can see my curve starting to come back down. I'm going to pause this while I fill in the rest of my values. Okay, so you can see that I filled in the remaining values, and I now have my graph, and that's what they wanted to see. So you could take a snapshot of this, take a screenshot of it, and put it in your discussion post. You could attach this whole Word document if you want. Okay. All right, so now we have made it through. Now we've made it through the end of step 4, and then where they said what shape is your graph, and you would just describe that in your own words. Okay, so the next thing we're asked to do is with our circle is to calculate the arc length for a 45-degree angle on your specific circle. So with my circle, I know that the formula for arc length is the radius times theta. Now remember, theta needs to be in radians to use this formula. So my radius, my diameter was 4. My radius would be half of that, or 2. And then my theta, my angle, we know that 45 degrees is pi over 4 in radians. If we didn't know that, we can go ahead and calculate it using our conversions. Okay, so if I multiply that, I get pi over 2, or you can just calculate it with your calculator. And I get about 1.57. Okay, so I noticed that my distances were about 1.5. Again, my measuring wasn't completely accurate. We knew that given my tools, but I was pretty close. Okay. They also want you to calculate the circumference of the circle. So they wanted you to calculate the arc length, and then they want you to compare that to your measurements that you got when you were doing your experiment. When you rotated 45 degrees, was it close? Was it right on? Were you super at this? Or was it off a little bit due to, consistencies with your experiment? Um, then they want you to calculate the circumference, which is 2 times pi times the radius, or pi times the diameter. In this case, again, my radius was 2, so I get a circumference of 4 pi, which is about 12.56. Okay, now notice, remember my distance I traveled, that should be my circumference, and I got about 12 for my total distance. So again, I was pretty close. They want you to tell 2 ways, after this experiment, 2 ways you could find the circumference of your circle. One might have to do with a formula, and the other might have to do with your experiment, so try that out. Okay, so the next thing that they ask us to do is to calculate the linear speed and the angular speed. Now, I'm not sure you timed yourself as you were rotating that wheel, but they want to know how long did it take you to rotate your wheel 45 degrees. I'm going to say it probably took me about 2 seconds for each rotation. Now, what does that mean is when you started, you rolled your circle a little bit. Okay, that was your amount of time for each rotation. Okay, now linear speed is how fast you went along the ground, and angular speed is how fast you move for each angle. Okay, so our angular speed, okay, to find that, we take our angle, right, and we divide by the amount of time. All right, so we traveled an angle of pi over 4 radians in 2 seconds. So I take pi divided by 4 divided by 2, because remember we rotated a 45-degree angle, which in radians is pi over 4. We're doing all this work in radians. Okay, so we divide that by 2 and we get about 0.3926-ish radians per second. So that's my angular speed. My linear speed, okay, that is how many inches per second I've traveled, not how many radians per second. So if I look at my distance, I traveled 1.5 inches every time that I rotated. So it took me 2 seconds to travel those 1.5. So I'm taking 1.5 inches, my distance that I traveled on the ground, divided by 2 seconds, the amount of time it took me to rotate. Now, it may have taken you longer or shorter depending on the size of your circle or your incredible speed at rotating a circle, but I get 0.75 inches per second is my linear speed. Okay, so that is what I would do. Estimate the amount of time it took you to perform each rotation. Find your linear speed by taking your distance on the ground divided by your time. Find your angular speed by taking the angle pi over 4 divided by your time. And finally, now here is the very last step that they want us to go through, and that is to calculate what the radius would have been given our calculations. Okay, so we know that our formula for linear speed is rho times radius. Now this is the Greek letter rho, and it stands for our angular speed, if I can spell. Okay, so what they want to do is take our calculations from the previous page and use it to calculate what the radius of our circle should be. Okay, now v, that's our linear speed, we found to be 0.75 inches per second. Rho, that's my angular speed, I found that to be about 0.3926. And I don't know r at this point. I'm pretending like I don't know the radius, and I'm using the speed to calculate my radius. Okay, that's what I'm pretending here. So to solve this for r, I would divide both sides by 0.3926, 0.3926. Okay, and when I do that, I get that r equals about 1.91 inches. Now, so based on my calculations, my radius for my circle would have been about 1.91. They will then want me to compare that to what my actual radius was. We know my actual radius was 2. So notice again, I'm off just a bit, and that has to do with my accuracy when I was measuring everything. So the better you measured, the closer these two numbers will be. And in this discussion board, they're just trying to get you to think about what a arc length actually is, what a circumference actually is. Are there other ways to find it other than using these formulas? And is there a reason someone came up with a formula rather than measuring it by hand all the time? Okay, so that's what the purpose of this discussion board is, I believe. This was to help you to navigate that discussion board, and I'm sure it was the most exhilarating 17.5 minutes of your life. If you have any questions, let me know.